Good afternoon, everyone. We are Team Avishkar Hyperloop. We are Team Avishkar Hyperloop from IIT Madras, and we welcome you all to this session. And we hope you all are keeping well amidst this pandemic. I am Abhinav Ramesh, one of the members of the business subsystem of Team Avishkar Hyperloop. And first of all, we would like to thank Team TOSC IIT Kanpur for giving us this opportunity to conduct this session. And today's session is aimed at introducing the concept of Hyperloop as a scalable technology and enabling you guys to get to know about our team, about our past achievements and our future goals. And we would like to mention that we strongly encourage all kinds of discussions and questions in between the sessions. So please feel free to post your queries or insights in the chat box. Before we begin, we would just like to show you a quick glimpse of our Hyperloop pod run, which was held in our campus itself. Yeah, to see our pod run after putting in endless efforts was a matter of pride and achievement for us. So as you could have also seen from the sheer joy on their faces. Okay, moving on. Let us first understand the motivation and the concept behind Hyperloop. So people throughout the world have started to realize the importance of sustainable technologies, and with that emerged the concept of Hyperloop. As mentioned before, Elon Musk first proposed the concept of system of levitating pods traveling in vacuum tubes between cities equipped with regenerative braking and on-tube solar power. He termed this prototype as a Hyperloop Alpha. One interesting fact here was that he wanted the student teams to work upon this concept and build upon it. So Hyperloop, being an all-electric system, has zero direct carbon emissions while also being faster, cost-effective, and weather-resistant. Here is a table from a case study our team worked upon with basic estimate practices for Chennai-Bangalore Hyperloop corridor. And as per our calculations, the travel time for the journey came out to be almost around 30 minutes. One of the key things to note is that the average carbon footprint for the journey comes out to be nil versus 27.6 kg carbon dioxide equivalents per passenger, which is the average of other modes of transportation. And with that, we can offset an emission equivalent to almost that being produced by more than 2 lakh people. Doesn't it sound amazing? Yeah, next slide. Yep. So here's a comparison of different modes of transportation between these two metro cities. And as we can see, Hyperloop turns out to be the fastest mode of travel, even faster than flight, if we take into account the security and the check-in time at airport. And consider a quick journey, Hyperloop also proves to be reasonably priced as well. Yep, moving on. There are mainly two types of scalable Hyperloop pods, namely passenger and freight Hyperloop. And as the name suggests, a passenger Hyperloop will connect people and bring the world closer by drastically reducing the travel time between two cities or even two countries. Another secondary benefit out of this will be the introduction of passenger Hyperloop will be the increased employment opportunities, as well as it will enable people to move out of their own city for job opportunities. Yep. And the other Hyperloop, as I told, was the freight Hyperloop. So this will have the same system as the passenger Hyperloop, except for the interior and the safety protocols. And this will also drastically reduce the delivery time and will make the business more profitable, as it will increase the efficiency of the supply chain. Along with that, as the research progresses, the pods will have a higher capacity to hold the freight and will also account for the higher freight demands in future. Another interesting fact to note here is that it will have a lower shipping cost than aeroplanes, and it is estimated to be almost being 8 times cheaper than aeroplane and only 1.5 times more expensive than trucks. Yep, and another fact to note here will be that it will also ensure the safety of shipments of goods. The freight Hyperloop is susceptible to harsh weather conditions, as Hyperloop is being run under vacuum tubes. Yep. So Team Avishkar Hyperloop is a diverse and an ambitious student team of IIT Madras, and we develop novel technologies to make Hyperloop a reality in India and worldwide. So over the years, we have proved ourselves to be Asia's foremost Hyperloop research group, and we have developed solutions with single-minded focus on scalability and cost. So yeah, over the years, we as a team have seen substantial development technologically. Moving on. Yeah, here's a depiction of the top Hyperloop student teams in the world. And as you can see, Avishkar Hyperloop is one of the major student groups working on Hyperloop technologies. Yep. And yeah, moving on. Right. So in September 2017, we started off by designing our first pod and test rigs, wherein we established a framework for pod development. And in mid 2019, we took a big leap forward and manufactured India's first ever autonomous Hyperloop pod. By March 2020, we completed the design of the second iteration of our pod, but due to the pandemic, we couldn't manufacture it. However, we didn't let this curb our enthusiasm, and we eventually built Asia's most advanced Hyperloop pod in May 2021. Recently, in August 2021, we also patented our Hyperloop tube design and did a live test of our prototype. We really look forward to keep advancing in our technologies and achieve greater heights. Yep, moving on. Yeah, so Team Avishkar has been working on various milestones, and in order to achieve our goal of scalable technology, in that journey, we have achieved some honorable awards and mentions. In Hyperloop competition, in SpaceX Hyperloop Pod competition 2019, we emerged in the top 10 finalists and were the only Asian team to reach. And as you can see, we also got an opportunity to meet Elon Musk and get a picture with him. We also conducted a pod run demonstration event inside our campus, and it is one of the main achievements because it is one of the only live pod run demonstration which was conducted in India. And yeah, it was demonstrated to Dr. V.K. Saraswat, who is a permanent member of Niti Aayog, IITM director, dean, and other industry representatives. Recently in 2021, we also won the most scalable design award and were in the top five in the several categories at the European Hyperloop Week. This also gave us huge confidence as it aligned with our goal of building scalable technology, and we look forward to achieving greater heights in the upcoming European Hyperloop Week 2022 as well. Yeah. So this year we have a diverse team of consisting of 71 members, and this pic here doesn't include all the people, but only half of the team which were able to come to campus, and we really hope that we get the complete team in campus as soon as possible. So yeah, moving on. Okay, before we move ahead, we would like to put forward a question for you guys. So what do you guys think are the amazing technologies used in a proposed Hyperloop transit system? Like what all technologies are being used or being implemented in a full-scale Hyperloop system? Any guesses or any? Yeah, please feel free to put your insights in the chat box.
Vacuum.
Okay, vacuum is okay, fine. I mean, yeah.
It is true. We need a tube which is
magnetic levitation.
Magnetic levitation.
Strong magnetic field.
Okay.
Magnetic powers.
That's right.
Magnetic powers meaning? Magnetic powers meaning?
Electromagnetism.
Yeah, true. Electromagnetism is a very important aspect of the Hyperloop.
That's true. Pressure difference, suction, okay. Solar power. Okay, solar power can be one of the sources of energy, but I'm talking about the main subsystems or main technology that are being proposed. So yeah, any other insights?
Excuse me.
Magnetic
I would like
levitation.
everybody to raise their hands and then we will unmute them.
Yeah,
Please, it's getting a little bit chaotic for us to understand what you all are saying.
right. And Shred, maybe you can take forward from here.
Yeah, sure. Thank you, Abhinav.
Yeah, thank you.
Yeah, so any one of you have answers? Any more answers?
Oh, yeah,
Electromagnetism
Pratyaksh, you can unmute.
Magnetic levitation.
Yeah, magnetic levitation is a valid answer, but that is just one aspect. Any other technologies you think would be useful for the Hyperloop, for the scalable Hyperloop? Magnetic levitation is one place where you levitate. What else do you need?
Akshat,
Any
you
idea?
were raising your hand. You would like to answer?
Magnetism and vacuum. Vacuum.
Yeah, vacuum is true. So vacuum is because you want to, like, if you take a normal train, you have a lot of air drag to it. So if you produce vacuum, you won't have that much air drag. Okay, fine. You don't have a lot of air, but you want something. You would want to move it, right?
Yes.
So
And
what
I
do you use
also
for that?
wanted to ask a question. Are there any current projects going in India overall Hyperloops? Means are they going to be built sooner?
No, could you repeat again? Pardon me.
Are there any projects going on India based on Hyperloops, like building on a large scale?
You'll get to know our plans, and maybe by the end of the session, I think your answer will be answered. If you just
Yeah, we will talk about it in the upcoming slides. Yeah.
Any other answers? So one is vacuum.
Okay, yeah, that's the right answer. I guess Shid, we can move on and start to explain about the subsystems.
Yeah, so as you can see, so the team is made of 4 major categories. So one is electrical, and there's electromagnetic, and there's mechanical, and there's business. So as someone pointed out, electromagnetism is a very key aspect. About 3 technologies of ours are being used in the Hyperloop. And so explaining each of these systems in a bit more technical way, let me move on. So the first up is propulsion. So now propulsion in a Hyperloop can be achieved mainly in 2 ways. So one is the conventional wheeled approach, in which you use an induction motor or a BLDC motor, or another one is a more fresher approach, that is magnetic propulsion. So this is again based on the laws of electromagnetism. So we use what is called a linear induction motor. So basically you take a rotary induction motor, cut it along its radius, stretch it out, and you get a linear induction motor. So unlike a rotary induction motor where you have a rotating magnetic field, in a one second. Yeah, so unlike a rotary induction motor, I hope I'm being seen, right?
Yeah, your video is visible.
Yeah, okay. So unlike a rotary induction motor where you have a rotating magnetic field, in a linear induction motor, you have a straight traveling magnetic field. So this is the linear induction motor our team has produced and a person walking upon it. So next up is levitation. So now levitation and Hyperloop can be of many, levitation mainly is by the laws of electromagnetism, but there can be many various technologies that can be used. Like one is electrodynamic wheel, another is circular induction motor, another is using permanent magnets in a particular arrangement. So as a team, we have tried all these setups, but all these are only in the prototype stage. None of them have been integrated into the pod as of yet. So the next up is high power systems. So high power systems powers the pod. So the high power systems consist of 2 major components. So one is the battery, another is the inverter. So the battery produces DC current, and the inverter converts the DC current to AC current. So a few components like the linear induction motor, that is the propulsion stage, would need the AC current, whereas a few components like which we'll talk further, like the brains of the pod, the embedded systems, would need direct DC current. Yeah, so as I spoke about embedded system, these are the brains of the pod. So they control every aspect, every moment of each pod, each component of the pod. So the next step is braking. So one of the most, Elon Musk wanted the Hyperloop concept to be completely contactless. So braking is one aspect where many of the other transportation industries, such as if you take the automotive industry, so the cars use frictional braking and not they use contact braking, not contactless braking. So we aspire to use contactless braking here. So what we do is, it is the same concept of electromagnetism, where we use eddy currents, which will produce a magnetic field in the track, which will repel the other magnetic field, and hence will lead to drag for the pod, and hence it will stop. The 2 advantages of braking is that it leads to much less frictional heat produced, and also much less wear of the braking component itself, and obviously overall efficiency is also increased. And the next up is chassis. So chassis is where all the components of the pod sit in, and the chassis team is responsible for making that and taking care of the proper stresses and strains for the chassis. And like this chassis which we produce is our latest creation, the 2021 pod. Um, so it is in the shape of the letter C if you look at it, and it is made out of carbon fiber. The next up is aerodynamics. Now, you might wonder a Hyperloop concept. In the Hyperloop concept, the pod is supposed to traverse in a vacuum tube. So what is the point of aerodynamics? What is the point of an aerodynamics team? Ideally, a vacuum tube will have no air in it. But if you think about it, in especially 340 kilometer, 340 kilometer Chennai Bangalore Hyperloop corridor, which we spoke about in the starting few slides, it is practically impossible to remove all the amount of air in it. There will be some amount of residual air present in it. So to counteract that air and to make the best possible design and reduce the amount of drag even in that residual air inside the vacuum tube is the aerodynamics subsystems job. And one more thing is that a Hyperloop concept is supposed to travel at speeds of about Mach 1, that is about speeds approaching the speed of sound. So when speeds approach the speed of, when air approaches the speed of sound, it behaves a little differently. So the aerodynamics team must also factor in that aspect of the air characteristics. So the next stop is suspension. Now, the suspension team is responsible for guiding the pod along the track and counteracting any bumps the pod experiences, and it is to provide a smooth and safe ride. And the next up is infrastructure. So the infrastructure team is a fairly new team in our infrastructure subsystem is a fairly new team in our subsystem. So the most so the Hyperloop concept involves two technologies. One is pod and another is the tube. So the tube part of it, we haven't focused on up till now. So in this tenure, in the year of 2022, the infrastructure subsystem would take care of all tube-related problems. And the last but not the least is the business subsystem. So what does the business subsystem do? The business subsystem takes care of outreaching events like one we are having right now to inculcate enthusiasm about the Hyperloop all around India and even the globe, and conduct publishing and studying economic case studies of mainly cities in India like the Chennai, Bangalore case study which you saw in the starting few slides. And the other one is finding sponsorship. We are a student-run team, completely student-run. All the decisions taken are by students, all the designs are by students, all manufacturing is by students. So we do not have any income as such. So we mainly rely on our sponsors' funds to fuel our ambitions. So the next up, summing up all these individual components which we spoke about, this is the overall pod. So you can see the front view of the pod and the bottom view of the pod. So as I said, so here is the semi-active suspension, which is made by the suspension subsystem. Next up is the inverter, which converts the DC to AC, and the next up is the linear induction motor right here, which is the propulsion subsystem, which is what the propulsion subsystem is. So the linear induction motors require AC, so that is why we use an inverter, which converts the primary battery's DC current. And the next up is the controls and communication, which require DC current, so we directly connect it to the battery. So that is our pod run, which we did after a lot of hard work and amidst the pandemic, when the country was ravaged with lockdowns and pandemic, we were there working there with complete COVID protocols being followed. There seems to be some issue. Okay. So the total distance the pod traveled was about 35 meters, especially because of the constraint of the amount of track we had. The amount of track we had were only 35 meters and not longer than that. But in the other case, we achieved a very high acceleration, about 0.5 G, which is quite appreciable and impressive. So our future plan for the pod aspect of the Hyperloop, the 2022 pod, is the lessons learned from the 2019 pod and the 2021 pod will be used in the 2022 pod. So the 2019 pod was of the 2019 pod, which was selected for SpaceX, and we eventually were acknowledged by Elon Musk, was the fact that it gave us immense determination that it is possible to bring in the Hyperloop concept into India. But it was an extraordinary achievement. But as such, in the technical aspects, the there wasn't many novel technologies involved in it. It was already pre-existing technologies and well-established technologies. So 2 years later, it was our goal to bring in more novel technologies into the game and make it one of the most advanced pods possible. So that resulted into the 2021 the pandemic pod, which became Asia's most advanced pod. It had many new. The inverter was one of the best inverters, most compact inverters, which was acknowledged by industrial people themselves, and everything was contactless other than the levitation aspect of it. So now the 2022, but the 2021 pod, the degree of novel technologies and the degree of scalability wasn't as much as we aspired to make it. So the 2022 pod will cover up for all those mistakes and make it the most scalable pod ever existing in India and even in the globe. So the 2022 pod will have on-pod levitation. So the 2019 pod and the 2021 pod did not have levitation integrated in it. As I already told you, that the levitation aspects were only in the prototype stage and not completely integrated into the pod. So the 2022 version will have on-pod levitation in it. And one more new system in it would be the thermal management system, which would remove heat from the heat concentrated areas and disperse it and distribute it to all over the place so that the overall temperature is quite less. And also another is increasing the efficiency of the linear induction motor. So the next up. So what I would like to say is that like the Hyperloop consists of the pod and the tube. So up until now, we have only spoken of the pod aspect of it. So now let me talk about the tube aspect of it. So our biggest reveal, I think someone pointed it out, to bring Hyperloop concept to India in reality and bring in a major project in India. So this is one step towards it, and you'll understand why after you watch this video.
One of the main questions that I was seeing is that you people are confused about, does it produce renewable energy, or like what's the energy aspect to this? So the thing is that some of the people in the chat also pointed out that this is a transportation vehicle, so obviously it will use energy. So how are we saying that it is a renewable transport or a zero carbon emission mode of transportation? Is that we will be, since Hyperloop is using electrical energy, so what we are aiming to do is that above all of the tube infrastructure that we have, we'll try to lay out solar panels. So according to our preliminary studies, we are confident that these solar panel system will be able to produce more than enough energy to power this Hyperloop transportation system. And in some cases, it might also produce extra energy, which we can supply back to the government or to other energy companies.
Yeah, so am I audible right now?
Yes, I think it's much better now.
Okay. So
Others, can you please give your feedback? Is it fine now?
We can.
Yes.
Yeah. Okay. Okay, someone is saying that it works in vacuum. So inside the pod, if the pressure is high, will it not burst? So see,
vacuum, the pressure will be low.
exactly. So actually the outside pressure will be much more than the pressure inside the tube. So there is a chance of the tube collapsing inside. But since, and that is the point. So our infrastructure team has been working on this thing only to make a design which is capable enough to hold the amount of pressure and not collapse.
So shall we continue with the?
Yeah, I think we should, let's continue with the presentation. Just before the discussion session, we can have a small Q&A session, okay? So just stop before that.
Yeah, so this tube is going to be 500 meters long with a diameter of about 2 meters, and is supposed to be inaugurated in the summer of 2022. And it's supposed to serve the purpose of being a Hyperloop testing facility for other student-run teams, not only in India but even in the world as well. And so you too could start a Hyperloop team in your university and make a pod and bring it into IIT Madras and test your pod's vacuum compatibility in a Hyperloop testing facility and get valuable data out of it. So now this tube is made completely by an infrastructure subsystem in Team Avishkar. So it's completely designed, validated, verified, testing. Everything is done by the students themselves. So we need some sort of mechanism to test whether our design would be actually good for the 500-meter long tube. So to test whether our designs are actually quite acceptable and feasible for the 500-meter tube length, we have built a 3.6-meter long vacuum tube, which is currently sitting here in IIT Madras. This is the 3.6 meter long tube, which was inaugurated by Mr. Pawan Goenka, chairman of InSpace. And this prototype was mainly made to test few parameters like temperature, pressure, buckling strength, stress, and strains involved in the vacuum tube when vacuum is put into it. So it achieved a low pressure of about 1 mm of Hg, which is only about 100 pascals, which is about 1,000 the pressure of the air around us. So 1,000th of 1 atm. So actually, this pressure is the amount of pressure at an altitude of about 50 kilometers. So you could say it's bringing air travel down to Earth. So that is how that is of very high. The achievement by this tube, the amount of vacuum reached is of very good, is plausible. And another aspect, and another thing we learned was the manufacturing capabilities. We already had an idea of it, but now we have a much more clear idea of as to how to build how to go about to build the 500-meter long vacuum tube. So our as somebody pointed out, so that they would like Hyperloop projects in and around India. So this is our plan, which we have. So first one is the phase 1, the proof of concept plan, which is about the 500-meter long vacuum tube of about 2 meters, and look at how it is functioning and the feasibility of it and the scalability aspects, the sustainability aspects, test it more on the 500-meter tube itself and get to know more about the tube and more familiarized technically in the tube. And moving after that, if all goes good, we are planning to build the 10-kilometer long tube, 10-kilometer long vacuum tube with a diameter of 4 meters about in the year of about mid-2024. And it is going to cost a huge chunk of money, about 200 crores. And then comes the final phase, that is a phase 3, the commercial Hyperloop corridor, which we are expecting to build between Chennai and Bangalore. As someone pointed out, this is one project which we are thinking of in the year of 2028 to 2030, which is going to cost a large chunk of money, about 9,100 crores. So as I spoke about this, so this is another slide talking about the 340-kilometer long Chennai-Bangalore Hyperloop corridor. So moving on, I would like to, this session was aimed at students and.
Before we discuss this question, let's have some answer some of the doubts they have in the chat. Can you go to the previous slide? Yeah, okay, like I have already answered the energy question that we'll be using renewable energy, using solar panels. Okay, so someone has asked that what are the control systems for if it is a computer to manage stability of the pod, right? So you've got some part of it right. So the controls and communications panel, what it does is it basically controls and gets signals and gives signals to the sensors that we have in our pod. So we have various sensors to measure the velocity, acceleration, displacement, and also like the Guru Murthy has said that to make sure that the pod is stable. So similarly, maybe to check the amount of energy left in our battery packs. So there are several sensors which are managed by the controls panel. Okay, so some people are asking that how do we be a part of this project? So if you want to be a part of Avishkar Hyperloop, particularly, you will obviously have to be a student at IIT Madras. Not necessarily BTech. We also have members from MTech, MS, even PhDs. So uh, whenever if you get a chance to be a part of IIT Madras, we would also love you to uh, get in on our team. And even if you get into some other colleges, we would encourage you to build up your own student team like Avishkar Hyperloop. There are many which are coming up, and we would love to uh, see more student teams coming up and coming to our this facility and testing your own pods here. That would be a really great feeling for us. Yeah. So I noticed that the slide had mentioned carbon fiber chassis. So is it a monocoque made with epoxy and carbon? Yes, absolutely. It is a monocoque chassis made from epoxy and carbon fibers. Okay, so someone is asking that the cost of setting up solar plants might be costly. So the thing is that this is a one-time investment. So once we have the solar panels set up, they're going to be there for a long time, and we can easily get the break-even cost recovered. Okay, someone is saying that which branch is a part of these. So one unique thing about our team is that we don't have any restrictions on the branch of the person. So e- it's not like only mechanical people or electrical people are working in our team. We have people from almost all of the branches, be it chemical engineering, be it metallurgical engineering, even aerospace engineering, or what else? Like almost all of the branches are there. And some of the mechanical people, they're working in electrical subsystems. Some of the electrical people, they're working in the mechanical subsystems. So it's completely based on your interest, and we don't do any partiality, or that we'll assign only the mechanical people the mechanical work.
क्या पीसने के लिए पूछना है ना?
Can you please mute yourself?
I'll mute whoever this is.
Okay, so someone is asking, is the Chennai Bengaluru Hyperloop government aided project? Okay, so no, not yet. It is not a government aided project. It is, we are still exploring options. There is a possibility of obviously the government's aiding us, and there is also, but the major thing is that since it is a very cost intensive project, so uh, even it's difficult even for government to invest in it. So what we are aiming is to bring together a consortium of private companies, so that each of them can contribute in their own part and help make this a reality. But this is still an in discussion topic, so I won't comment more on that. Uh, is it faster than jet aeroplane? I'm not. I won't say it's faster than a jet aeroplane, but I think it is comparable to a normal passenger airplane, which are used for domestic flights. Ideally, when it is fully functional, it will be. We are aiming for a speed of around 600 kmph. Okay, so someone is asking, will we have stops between the stations? So, so one thought on this is that since it is a very, for example, if you take the case of Chennai to Bangalore, so this route is going to take roughly around half an hour. So if we have stops in between, like a normal railway, a passenger railway, so it doesn't make sense to have a lot of stops in Hyperloop because we are already traveling at a very high speed, and if we have stops, it's going to make it very useless. So again, there will be a lot of time wastage. So we are planning to accommodate one stop in between, which could be like an added junction. For example, in Vellore, there is a possibility. So, yep. How will people enter and exit the vacuum sealed pod? So this is actually a very good question. There are a lot of discussions going on around the world. Many people have given like several different kinds of solutions to this. What we have thought here is that, in fact, this is actually an open-ended question for you guys also. You guys can also think upon this. I'll give you what we have till now come up with is that we can use a vestibule system kind of thing. So if you have seen some of the space movies or maybe Interstellar or Gravity, you might have seen that there is a small chamber in between the space station and the space. So where if you enter there, you lock yourselves there, then there is a change in pressure, and then you go back to the other side. So we are planning to do a similar thing that when the passengers enter into the pod, after that the pod is enclosed in a closed chamber and the pressure is dropped and it is opened to the tube. So similarly, while coming out, the pressure is again increased and they're taken out of the tube. Can it take turns or only straight paths? So this is also a very good question. So till now, since we are traveling at very high speeds, so it is obviously very difficult to travel in a straight path. We are trying to find ways to how we can accommodate turns at very high speeds, but obviously it's going to be very difficult. So majorly is going to be a straight path only. Okay, I think for now we have had enough questions. We have a discussion session also planned for us. So Shrid, why don't you continue with that? We'll take the rest of the questions later. Yeah.
Yeah, so we obviously wanted the session to be more interactive, and it is being quite interactive till yet now. So to make it more interactive, we have prepared this open-ended question about pod failures. So if suppose there's a pod failure within a tube, there's one. So obviously there wouldn't be one pod going in the tube at one time. There'll be multiple pods going one after the other. So if one pod has had some sort of pod failure in an accident, what will be the feasible solution so that the following pods also avoid further collisions? Like what is the next measure you'll be taking? Any ideas you have?
So please feel free to like put your solutions in the chat. So this is an open-ended question. Even we are not sure of it. Like what would be the final solution that will be implemented?
Is quite debated in the Hyperloop community, and it's quite a huge question over there, and it must be solved. So I guess you people could also contribute to it.
Anything that comes to your mind? Yeah.
Actually, can we use any type of EM waves like we use in sonar? We use sound waves, so like that EM waves, which will help to determine the time taken to transit the EM wave which we have sent the.
Yeah, so that is basically LiDAR, how LiDAR sensors work, right?
Yes. So will that be a possible?
we do have LiDAR sensors integrated, but I don't think so LiDAR sensors can get the distance from one pod to the other. It would be quite a tough job to do. But your solution is definitely valid. If we use more stronger waves, then it can be possible.
Right. So someone is saying that we can stop the whole pod system by stopping all pods wherever they are and increase air pressure in the tube as fast as it can be safely. See, that is a good solution, but there is one problem in it, that we don't want the whole system to collapse. We want, if there is a problem with one pod, we don't want the other pods to suffer too much, because that will be a very, very difficult thing for the other passengers. So what we want is that we quickly stop the pod with the problem and make sure that the other pods are not bothered too much. So we just want them to have a quick stop, and so that till then we take out the faulty pod, and the other pods can then continue the journey. Someone has talked about TCAS, traffic collision avoidance system. So yes, we could develop a system like that for Hyperloop also. That's definitely a good solution.
There's one here by Gomez saying that he wants to put a magnet in front of a pod and behind a pod to stop, repel it and take it to it.
Okay.
I mean, you'll need really big magnets to do that.
Definitely. Okay. Someone has said that pods can have GPS positions on every other pod. That's definitely something we can look upon. Okay, when the pod is moving, as soon as the pod stops levitating, it could complete a circuit and switch off the tube. Okay, that's something out of the box and interesting. We could try something like that, definitely, yeah. Okay, we could make an extra pod available on some distance and then exchange it. This would come under like how to rescue the passengers of the faulty pod. Yeah. But definitely this is also something we'll look into. Okay, is it possible to have like a diversion system? This is also again how to make sure that the faulty pod comes out of the way of the other pods. Right. Yeah. A lot of people are talking about like multiple tracks, which is like a separate track at some distance, for these faulty tracks to get into and give way for the other pods. We can put trackers on them. That's definitely one solution.
People seem to be very interested in Hyperloops. I hope they also start a Hyperloop team in their university. I think
Saksham, you're not audible.
You're unmuted.
Yeah, sorry. Yeah, I'm saying that someone has asked a question about what about the air supply inside of the pod, since it's isolated. So yes, inside the pod, there's obviously going to be a normal atmospheric pressure, which we'll maintain using similar systems as we have in aeroplanes. Even during emergency, we'll have similar mechanisms. For example, the oxygen masks, they are coming out of the top of the plane, so we'll have something similar to that.
Yeah, so because of our past accomplishments, we have been covered a lot by the media also, and have been consistently interviewed by them in 2019 and 2021. And you can read many of our articles from various media outlets. Moving on, we are a student team, so we cannot sustain ourselves without any funds. So we would really like to thank our sponsors in that aspect. And the amount of support we have got from them is of immense importance and is close to our heart. And they've also contributed a lot of their expertise to us to help build many of the technologies we have built up until now. And moving on, we finally conclude the session, and we thank you for your time.